Okay. Yeah. You're welcome to class. This is Mastering Cybersecurity, and the training will be centered on real life events, real life instances that we can learn from. And the emphasis is on building skills, cybersecurity skills, and these skills can now be tailored to different branches of cybersecurity. Cybersecurity has become not just a household name, a faculty in itself. And or would I say a college? And there are so many areas of specialization within the field of cybersecurity. I'll be exposing us to some of them. Some, okay, we had a webinar around it. So, and we saw some of, for those of you who were not there, still going to mention where we're going. And then as we go on this journey, I'll be telling us as we take some modules, I'll tell us these are the skill sets I associated with this module, and these are job vacancies or job roles job roles you can apply for, or areas of specialization. Okay, I want to be a data privacy professional. There is a module for you on this journey. I want to be GRC, I want to be this, I want to be that. So we're going to expose you to lots of these areas of specialization and then equip you for the journey ahead. So let's get started. These are the objective. You've got going to gain the fundamental principles of security, and then with that you'll be able to understand management processes, risk management processes, security controls, governance, and code of conduct as for cybersecurity. Then you'll be able to understand what we call business resilience. The concept associated with that, business continuity, disaster recovery, and incident response. Then be able to understand control concepts. Another very key aspect, a very critical aspect of cybersecurity, which is control. So we're looking at physical control, logical control, and by extension, administrative control. So we'll also be looking at network security, threats and attacks, attack vectors, threat vectors, and agents and the likes. We're going to look at it there, and we'll also look at vulnerability there too. Then we're looking at security operations. Those of you interested in SOC, Security Operations Center, and you're interested in becoming a SOC analyst, you will be looking at concepts around SOC when we get there. So it promises to be a good ride. Module 1 talks about security principles, and chief of it is CIA triad. We shall also see by extension in the basic foundations of cybersecurity. Outside CIA, we're looking at authentication, we're looking at authenticity, we're looking at non-repudiation, we're looking at accountability and audits, then privacy being one of the pillars to cybersecurity, but the critical pillars of cybersecurity is the CIA triad. We shall be looking at risk management, same module 1, security principles. We shall also be understanding the different code of ethics from some professional bodies and some regulatory bodies like NIST and standards body like ISO. So we expose you to these code of conduct, their tools of cybersecurity practice that should govern your conduct as a cybersecurity expert. Okay, should be understanding the governance processes from policies, procedures. When we say security or governance of security, what are the measures put in place? What are governance responsibility? Generally, governance means providing overall direction and control. But what are these measures that amount to overall direction and control? So some of them are mentioned here: policy, procedure, standards, regulations, laws. Looking at frameworks too. And then within that module, business continuity, disaster recovery, you can master your skills around this. You can choose to be an incident response analyst, handler, playing the first role within that domain or module or that area of competence, let me put it that way. So you can skill up along these paths and you become a professional business continuity expert. Then module 3 talks about access controls, physical access controls, logical access controls, and then permissions, authorizations, and the likes. So I'm looking at different kind of permissions assigned on resources. Could be network resources or even off network resources, but then it's generally digital resources. So you can see the 3 basic controls there: DAC, MAC, and RBAC. So that being discretionary access control, mandatory, and role-based. Within this concept, we're looking at least privilege and then some other permissions associated with access to resources. Then within the scope of this domain, for everything here is network security. Please prep your mind. At this point, when we get there, before going through the security details, we shall be looking at networking. Basically, it's not going to be an extensive computer and networking class, no, but we'll be looking at the fundamentals of computer networks. So from personal area networks to, basically we call them local networks, which include personal area network, local area network, down to wireless area network, then up the chain or the ladder to campus and then metropolitan area network, and then we finish it up at a wide area network and wireless wide area network. So we shall look at this network architectures, different, I mean, individually. And excuse me, the security measures for each class. Then security infrastructure, network security infrastructure. Within this, like I told you earlier, it's about networking and then security measures within the network. Then within that module 2, we shall be looking at security operations. We're talking just like we have data centers, we have security operation centers. So we expose you to a security operation center and how it is formed, how you can build a security operation center. You can have one built within, yes, you can set up a system with, we'll talk about it when we get there. But we don't go, with that knowledge, what we intend to do here is, number one, you'll be able to now strategically choose a specialist route from this journey. Every cybersecurity expert will tell you there's always the need for specialization one, but then there's the need for foundation, a sound, solid foundation where you understand the fundamentals of cybersecurity. So we're going to look at these concepts too, like you find here: security policies, acceptable use policy, bring your own device policy, data leak policy, privacy policy, change management policy, you find here. So the prerequisite is that there are no prerequisites for this course. You don't need to be a tech expert. Although from the introduction, I could pick that one of us is a software expert, software developer. So, well, that doesn't mean we'll have to have a tech skill to join this trade. So please, this journey would expose you a lot to tech, but then or cybersecurity from the grassroots. Then, before we go into talking cybersecurity, because when we say cybersecurity, something comes to mind: protection, safeguard, or let me say safety. Hope you're getting me. For some people, when you hear cybersecurity, what comes to mind is attack. But for us, this journey, what comes to mind is protection. Now, the various measures that can be implemented to protect differs. So the onus is on us to know them and also know when to implement what protective measure, security measure should be in place. Basically, there are security measures that are preventive, some are detective, some are corrective, some are deterrent, and even some are adaptive, some are perfective. As we have duality of security measures, a multiplicity of security measures, and the likes. So you can't implement, or you shouldn't be implementing corrective when the need for preventing should be enforced, and vice versa. So that is what makes you different from any other person as far as the knowledge of cybersecurity is concerned. So you are a pro, you should be able to say, this is what is good with on this matter, on this instance. At this instance, so we should apply this measure, and get this will help us get the desired result. So these control security measures are product-based, vendor-based. Some are not vendor-based. Some are internally crafted or developed, yes, by institutions, proprietary applications, or proprietary security tools. So all of these, you would be able to determine which is best, whether your institution should develop a proprietary solution or application or tool for security, or you should go ahead to procure one, which is best. The skill you gather from here will help you make such informed decision at the right time. So I would say that before we go in depth into cybersecurity, I want us to look at three aspects of technology: information technology, disruptive technology, and operational technology. The reason I brought this into it is because what are we protecting? We're protecting resources. We protect these resources. Some are digital, some are human. Hope you're getting me. Some are processes. Yes. Can processes, organizational processes, amount to a resource? The answer is yes. The basic understanding of resources are either tangible or intangible objects. Could be tangible as laptop or computers, the network, and the physical infrastructure on the network. But there are other infrastructure on the network that are not physical. I mean, to put it this way, that resources in a network would be, or the network would be, let me say, in a system, in a digital system, resources can be physical, resources can be logical, resources can be virtual. Now, please note, and I'm going to explain. In whatever state these resources might be, requires some protection. But then how would you be able to protect a resource you do not know? So first thing first, let's understand what these resources are and in what categories, so we can now learn how to protect them. So let's have the concept of information technology. It's not a novel concept anymore. At the time, it was information communication technology, and then all of a sudden the C was taken out of it and it became information technology. Doesn't mean the C is no longer relevant within this field. Of course it is. That C is what translates into what you call telecommunication today, or what you call networking, or computer network. We'll talk more about that later on, not now. So then, what is information technology? I will, by extension, include a concept called information systems, so that we have a balanced view of an organization's infrastructure technologically. There is information technology, there is information systems or information system. And are they the same? Is there a point they are not? Is there a point where they interconnect or where they can be separated from each other? For simplicity's sake, without going into some exhaustive definition, I would say that information technology is just three things. I'll put it mathematically as IT equals hardware plus software plus data. If you fuse these three together, you have information technology. Now, when we say technology, it's simply the application of scientific knowledge. Research has been made, knowledge has been gathered, and that knowledge can now be applied. Now, that knowledge can be applied for the purpose of generating information, for the purpose of gathering data, analyzing data, storing data, transmitting data, sharing data, and using data, and also protecting data. We say that is what information technology, just like we have technology associated with other fields. But then within this scope, it's just basically hardware, software, data fused together. You have information technology. But you may want to ask me, where is the network there? Isn't the network part of information technology? You are correct. But basically, we'll say that the computer network falls within the scope of what? Communication technology. I hope you're getting within the scope of communication technology. That's where computer network basically fall. So, by extension, now let me take you into information system. Please, I would entertain question anytime. So, if you have a question, please just you can raise up your hand. Okay, someone asked, can we have the manual to go? Definitely. Definitely. Sorry, I'm calling you by your device name. Definitely, you're going to have access to the manual, to the text. So, now information system for understanding sake. But please, I said something. I said, if you have questions, if you have any question, do not bother to wait till the end of the session. You can raise your hand. I will accommodate your question. I will entertain your question. And if you cannot, perhaps you're at work or you're somewhere, you're in transit or you're somewhere where you cannot talk, maybe due to the noise or due to the need to be quiet there, you can hit the chat segment and drop the question. I'll read and respond appropriately. Now, information system is the embodiment of information technology, which is hardware, software, data, alongside now communication, or we say telecom or network. That's one. Now we already have three, right? The embodiment of information technology. And it also includes what? Three other things: people, processes, and what? And network. So let me take it again. Information system. Please, like I told you earlier, I don't want to take you to the route of extensive definition and all of that. I just want to make it very straightforward and direct, so you can retain the knowledge. You can, at least, if you're asked, you can, without having to think and having to, okay, how do I explain or define it? Just tell them this is what makes up information technology. This is what makes up the information system. So, information technology is the embodiment of information. Information system is the embodiment of information technology alongside people, processes, and what? A network or communication. So if you use these three on this side with the three in hardware, you have what we call information system. So what we have today and what we're prepping professionals for is not for information technology anymore. We're prepping people for information system. Even if you're taking just core IT courses like networking, like computer engineering, programming, or software development, as the case might be, the whole essence is to ensure that you're providing value. Value for what? To an information system, to a system. But the organization itself, you will be working for, consulting for, as the case might be, is a system. And it's an information system in operation. So you need to have that understanding of information system than just having the understanding of information technology. And that's why I brought that in. So let's see some of the examples of information technology. You can find there. We've got internet, we've got cloud computing, and down to AI, Internet of Things, IT governance, and down to disruptive technology. These are not all there is to information technology actually. The list is quite long, And there are some concepts in information technology that have been metamorphosed. Some have become extinct. Some have been replaced with novel technologies. Then the essence is that we have an understanding of technology. That leads us to the next slide, which is disruptive technology. I love to talk about this kind of technology because it is the technology of the now and the technology of the future. Some few years ago, but when I say few, more than 10 years now, I was going through an article, and the author said, should be like 15 years ago, really. The author said that technology, information technology will remain and still be relevant for the next 100 to 150 years. And I'm too sure by then we may all have gone. I'm too sure 100 to 150 years we may all have gone. So, but then if technology will still be relevant till that time, and the rate at which it is evolving is faster than we can think. I can remember I think the one-time MD of Intel, I don't know if he still remains the MD, once said that processors would be newer versions. That's computer processors will be evolving every 18 months. That was a big challenge actually for who? For software developers, a big challenge for primarily software developers and also hardware developers. Those who develop the I, the O, and the S, other than the P. Sorry, I just said iOS. I need to explain that. Basically, in a computer system, there are 4 basic components. We've got the I, the input components or devices. We've got the processing components or devices. But the processor is not just, when we say the processing component, we're talking about the CPU, which includes the arithmetic logic unit, the control units, and what's this stuff called now? I'm trying to remember. Don't mind me. So we got the arithmetic control and the logic, you got the control units and one other units or so. Okay, yes, primary memory. Yeah, just remember that now. So it means the CPU is not just a component, but a set of components. So we got the output components or devices, then we got the storage components devices. Now, aside these 4 components that make up a computer system, we now have what we call peripheral devices. Those devices that are that can be attached, they are attachable, and they are detachable from a basic computer system, like your printer, your scanner, a camera, and the likes, memory card, and the likes. So these are peripherals. They are detachable. They might fall within the scope of inputs, outputs, or storage, as the case might be, but then they are peripheral. Now, when we made that statement that processors will evolve every 18 months, I just made I knew that was going to be a very big challenge for developers, a big challenge for other hardware manufacturers or developers too, like the input producers, the outputs, the storage, because the iOS all interact with the P. Also, the peripherals all interact with the P. So if the P is evolving so fast, 18 months, and well, it means the I, the O, and the S, and even other communication devices and peripheral devices that are connecting with the system have to evolve in that direction. Else, there'll be what we call lack of interoperability. The lack of interoperability because one would be working at a speed higher than the one connecting or communicating with it. So at the time, there'll be buffer or there'll be communication will be lagging, and I mean, there's so many challenges associated with that. So he said that with technology, for a technology that is not novel, I mean a processor. Now, we now have technologies that are novel. We have technologies that have come to disrupt normal business norms, normal lifestyle, technologies that have come to disrupt what the tradition of things, Now, for instance, before now, if you want to see a movie, you either go to a cinema or you watch on your home TV. But now, if you want to see a movie, you don't have to go to a cinema anymore. You just hit one of these online movie platforms like Netflix and Showmax and the likes, and you can see a movie at the comforts, at your own comforts. You can be in the emotion or in transit, just on your phone. You're watching a movie. You don't have to get home to watch that movie. You can be on a long transit that will last for like an hour or two, and you have a season movie you've been following. You can follow it. That's the technology that has come to disrupt the tradition of things. The tradition before that time is that you get to and watch, but today the tradition is changing. So I mean the method is changing. It's no longer as it used to be. So any technology that comes to change the norm becomes disruptive. It was this professor called Clayton that christened it disruptive innovation in 1995. But over time, the name evolved from being innovative to now being what? Technological. So we now call it disruptive technology. The list is so long. Examples of these types of disruptive technologies, the list is so long that it's not stopping. It has continued for so long. A very good one is the chatbots, which I strongly believe all of us would have had an experience or a taste of, like Copilots, like Gemini, like Meta AI, and some other chatbots, and also virtual assistants. Now, back then, we had what we called a decision support system that looked so distant away. Looks like it's a type of information system developed for middle to senior level management. But today, we now have virtual assistant providing DSS to basic operational responsibilities, operational tasks. So it means what was designed for decision and policy makers is now available to the layman. Isn't that disruptive? Of course it is. So we're going to look at some of these disruptive technologies. And the reason I brought this in also is because of the need for protection. The onus is on us to provide protection for these technologies. You would agree, some of you will agree with me that basically AI has been a thing of concern to the industry, the tech industry. Why? In the light of what? Security, not in the light of value delivery. Because AI is delivering value, we agree. But how safe, how secure are you with AI? Currently, chatbot has entered Gen 4 from Gen 1. The current version is Gen 4. And at Gen 1, I learned that it's going to Gen 7. And with the new year came Gen 4. We're still talking about protection for chatbots, even at Gen 1, mid generation 1. And we're already talking about Gen 4. So isn't there a need to protect users of chatbots? And then when you interact with any of these chatbots, don't you ever care what you punch in there, what you submit there, what's the data you provide that makes the technology interact with you? Don't you ever bother where it goes? How is it stored? How is it used? All of this come within the concept of what? Privacy. But at the same time, can what I provide there, can it be used, or what I supply there, and the way it answers me, can it be used for or against me? These are security concerns. And to date, it is still a security concern yet to be addressed universally. So these are examples of disruptive technology begging us to provide security, safeguards, countermeasures, as the case might be, as far as cybersecurity is concerned. We've got blockchain. It hasn't been exhausted yet. We've got robotics. You can see the lists as it continues down to virtual, augmented, and mixed reality. I don't know how many of these you've used. I don't know what your experience has been. I don't know if there's anyone in the class that may want to just share with us a negative experience you had. Yes, I want the class to be interactive. Is there any of these disruptive technologies you used and you had a security concern. Is anyone in the house or in the class who would share an experience? And just tell us you had a security concern. It's not just the value it delivered, but the concerns. You perhaps maybe you lost something. I will share one with you at for a corporate entity, a bank in particular. But let me hear: is anybody in the house who had an experience of that requires some security implementation using any of these chatbots? Can I hear from any of us?
I can contribute to that.
No?
ChatGPT is a popular machine learning large language model that is used worldwide. The security concern with ChatGPT is that the data you put into ChatGPT is used to train the model, so it's going back in there. So your data is not safe. So it is organizations are concerned about what their employees in particular put into ChatGPT, because if you put PIIs, information that contain to customers or something, the model is going to use it to train the model. So somewhere in another part of the world might ask for that information, and ChatGPT will relay that information to you. So it's a big concern. They introduced an enterprise version that that they don't use to train the model, that you can use to train the model, but there's still a level of trust that has to go into that for people to actually believe that.
Thank you, Samuel. Thanks for that contribution. Can we hear from someone else? Of course, thanks, Samuel, for bringing that, because the instance I'm going to share with you, true life story, actually is with ChatGPT. I don't want to use the word ChatGPT. I like to use the word chatbots, because that's actually named for those that's type of disruptive technology. Okay, Israel. Okay, sorry, Israel John. Is anyone who's had an experience and it wasn't funny at all, and you think, this is an issue of concern, I think they should provide security here? Okay, who else want to say something that you, or perhaps a story you heard and you think, this thing is creating concern for us? Okay, let's hear from you.
Can I go next?
Please go.
All right. So recently, I was invited to conduct a risk assessment on one AI application. And what I discovered is that during calls like this, the AI takes everything, does the snapshot of whatever is going on. So the risk there is, and the security concern there is that whenever they are having sensitive projects, in quotes, in terms of bidding, in terms of, for example, you are doing some government project that is restricted to a particular environment that is not supposed to go outside that environment, it takes everything. Do you understand? So it's a major security concern. And like you said, from the security point of view, is our responsibility to protect and to ensure that we safeguard the environment we are working with. So it was a bit of challenge, but then I didn't know such a thing existed until I conducted a risk assessment on that application.
Thank you, Emmanuel. Thank you for that contribution. Let me already share this. There's one of our big banks. Let me say, okay, Tomiwa, you want to say something? There's one of the very big banks in Nigeria that's allowed the use of one of the chatbots. And the task given to employees, primarily at the headquarters, some of those tasks required delivery within 30 minutes, 50 minutes, less than an hour, and all of that. So the next thing, there's a disruptive technology that can help us really. Okay. So what they simply did was just copy without filtering the task and copy and paste that inside inside a particular chatbot. And the name of the institution was also stored, like someone told us. The head of machine learning is able to learn from what you're entering. So something that happened. Why other institutions were using, also posting questions or concerns that they required the bot to respond to. the bot was now mentioning that particular bank. Like, for example, I hope you're getting it now. For example, bank XYZ. So whenever some issues were raised or someone is using it, the bank was not making the bot was not making reference to. It became a concern that a security policy was passed banning the use of chatbot with a disciplinary action attached if anyone is caught using it. Now, the question I would have loved to ask is, these technologies aren't there for our good? Of course they are. But then how can we implement, or number one, how can we adopt these technologies into our operational processes in a way that it will not amount to risk? I hope you get it. It will amount to risk. Rather, it will be of value and value alone. We're not saying risk would be zero. There will never be a time you either acquire or use resources that the risk, but there's something called inherent risk. We're going to talk about that later on in risk management. So every resource, be it like I illustrated, I mentioned earlier, be it physical. Now in the light of digital resources, so please, we need the scope of IT. When I mean every resource, please just take it that way. We need scope of IT. Can be physical, can be logical, can be virtual. Let me just give a good example. All the tangible resources, technologically, are physical. All the instructional resources like programs, codes, software, they're all logical resources, including data. Why? Although data can also take virtual states, I hope you're getting it. So, because there's what we call data in transit and data in storage. So, data in storage is called physical, and data in transit is called logical. So, data can also take virtual states, truly. But then, please, I'll talk more about that later when we talk maybe data privacy, and we'll talk about that. There's so many states data can take, identities data can take. So, logical resources primarily are what? Software, programs, instructions, as the case might be, not work instructions or instructions to computers or or algorithms, let me use that word. Then virtual resources like cloud computing. Cloud resources are virtual resources. You can see, like, a very good example of another good example of virtual resources is virtual machines. So you can virtualize your device with, for instance, you have one of the Linux operating system virtualized on your computer, or you can even virtualize Windows or any other operating system on your computer, because that's a virtual resource. So resources can be physical, can be logical, can be virtual. Now, you are expected to protect these resources, irrespective of the state. Now, it's quite easy to protect the physical resources. But what about the logical resources and the virtual resources that are not visible to the eye? You can't access any of the resources without turning on the computer. In fact, without even sometimes connecting to the network. So, and these resources, up until quantum key, are represented, as far as they're logical or they're virtual, they are represented in zeros and ones. So how would you protect this? If you understand bits, the value of bits to this state of resources, basically the logical resources, then you know how difficult it is to protect them, and how, at the same time, how easy it is to compromise them. Oh, it's not within the scope of this class, and perhaps might not be within the scope of this job. But if the need arises for me to talk about bits and its implication on cybersecurity, it's a seminar. Yeah, I've done lectures on that. But if need arises for me to talk about why we constantly have compromise, irrespective of the evolution of digital security resources, that's from endpoint security to gadgets that are able to filter, like routers, firewalls, and even routers that have filtering capabilities in them. Why, in spite of all this digital, I don't know if any of you have given me the thought that in spite of this continuous release of new versions of technologies that provide security, we still report or record cases of what? Cyber attack. if we decompose it down, everything still narrows down to bits, the use of bits. But we're expecting that quantum bits will help address that, since it can represent data in two states at the same time. It can represent data as 00 or 11 or 10, and even down to 4 or 5 states as the case might be. But please don't let me go into that. I don't want to mess it up for anyone at this level. A few of us will understand what I'm saying, but then it's quite technical. So, but at that state, at that granular state, the most granular state in the field of computing is 0 and 1, binary. And at that point, that is where some cyber attack are most successful. So that's a thing of concern to you and I. That's what can we do down to that state, that most granular state of data, granular state of technology. How can we start protecting resources from there up? So please, we'll talk more about this later on when we get to security operations. Yeah, we'll talk about it. So please, these are disruptive technology. These are not all the disruptive technology. For instance, fintech is not here. Let me see what else is not here. Fintech is not here. There are other disruptive technologies. Let me see, is crypto here? Oh, crypto is not here, for instance. So can you see that the list is long? What we have here is just about 11, if I'm not mistaken, yes. And I've already mentioned 2, and we can go on and on. Now, this is important for us, so we can start thinking when we hear issues of security compromise, how do we protect? Please, this is the emphasis or a take-home from this segment. As far as these 3 technologies are concerned, number 1 is that the onus is on you to know technologies. Yes, by their design, their operations, the way they deliver value. Technology can be exploited at different states. I mean, in particular technology can be exploited. So the onus, you want to protect a network, of course you should understand the network. You should understand what makes a network, how do computers or devices on the network communicate, and so on and so forth. Hope you're getting. So the last category of technology here is operational technology. This wasn't a thing of concern years back as far as cybersecurity is concerned. But it has become a thing of concern now because of the exploitation of these technologies. Excuse me. There was a time, I can't remember, I think that was when Barack Obama was the president, or Donald Trump's first term in the office. There was a time a gas supply system was disrupted in the US. I can't remember which of the states now. That gas.
That was Biden.
Okay, that was Biden,
last
right?
President, and it happened recently as well. It has happened 2 times now to US from China. It's a massive attack.
That gas, thank you, Manuel. That gas supply is disrupted. Come on, what has gas supply got to do with information tech? Is it technological design, technical implementation for gas supply? Is it IT? IT is involved, but we wouldn't say it's IT anymore. We'll say it's what? OT. Hope you're getting it. Heineken, some years ago, I can mention me. Please, I will strongly comply with the rules of data privacy. Like the name of the bank I illustrated, I did not mention. So please, the same thing too. You should, it's part of the code of the tools of our profession for privacy reasons. There are some institutions, even if you have the name, as long as some of this information, and if that information is not in public domain, please, you do well not to disclose the identity of the institution. But if it's in public domain, like the case of CrowdStrike and Microsoft's operating system updates, of course, we can illustrate that. We can mention the name because it's in public domain. Please, it's part of our tools. You don't mention names of any institution that has suffered a compromise if the issue suffered or the risk is not reported in public domain. But if you can find it on the internet or any other form of communication media, please, you do well to mention their name. Okay, now Heineken even reported this, that their production line was hacked And those who have it took over the entire production line and disrupted the workflow, the production workflow. That sparked something in them, and they had to enforce IEEE cybersecurity framework across all INEC institutions all over the world and sub-institutions or subsidiaries. Why? Because of that incident. Now, would we call that information technology? Of course, there's IT in their operations, but then that's operational technology. I hope you're getting it. Now, operational technology are the technologies in the general, most of the technology you find in operational technological system or in an operational system are not the everyday IT devices like you and I know. Of course, they use some gadgets. They look very much like computers, but we can't call them laptops or desktops. I've had encounters with some of these operational systems, so I know how they look like. So some of them, basically, the operational technologies basically are programmable. That's why we are recognizing them within this field. They are programmable. That means we can have a firmware. Most of the programs are actually firmware, not installable and uninstallable software. So they got firmware programmed into them, but then as long as they run, there are algorithms instructing their workflow or their operations. Of course, there is need for what? For security concern. So operating technology is becoming a thing of concern so much. It's still cybersecurity in OT is still novel. Please, I'm saying this because I'm trying to enlighten some of us to decide or get us informed as to which area we can specialize on. OT is an area you can specialize on. If you are an electrical electronics engineer and or you're a member of IEEE, of course, you can take their certification in cybersecurity. All of IEEE certification, they have a framework on cybersecurity, and all the certifications in IEEE and cybersecurity are OT based. Hope you're getting it. So it means that should you specialize in security of OT systems, so it means you will be working more within the manufacturing or production cycle than you'll be working in, for instance, telecommunication or banking, because your skills is not tailored. Your cybersecurity skills are not tailored to that aspect. I hope you're getting it. So please, you can look at that direction and skill up along that path as far as cybersecurity is concerned. So examples of operation technologies include industrial control systems, SCADA, called the quality control and the data acquisition. The very popular industrial control system is called PLC, programming logic controllers. And example of PLC is semantic, step 7, there's step 5, there's step 7. And then we have the computer numerical controls and so many of these other controls. You understand? We find these CNC, find it more within this fluid related gas and all of that. The fluid related industry like oil and gas and the rest. So I'll cap it up here. This is not OT class. No, OT has its own journey, main career path. But then I decided to bring this on board so that we can know that, okay, these are the 3 categories of technologies where cybersecurity is mostly needed. So please do not forget that across these 3 technologies, information technology, disruptive technology, and operational technology, there are people. Yes, people work there. So that is what brings me back again to what? Information systems. So it means in an information system, we can have IT, we can have OT, and we can have what? GT, disruptive technology. So information system is the embodiment of all of these 3. So we can have all of these 3 within an information system. We can have just one within the information system of an enterprise or an organization. But please note that the onus is on you and I to protect any of these technologies wherever we work or for whatever clients we consult for. Are we together? So I don't know if anyone has any question to ask before we delve into cybersecurity. And the next 5 minutes should be done less. Is there any question around the 3 Is there anything I said that is not clear? You want clarification, or you want further explanation on any of the three? Information tech, disruptive tech, and the OT, operational tech. Okay. In the absence of questions, let me move on and see cybersecurity. I said something earlier, but when you hear cybersecurity, either of two things come to mind: safety or protection on one side, or threats, attack on the other side. At least one of the two will come to mind. Are you hearing me? So, but in this journey, we'll be looking at it more from what? Protection than from the attack. Of course, there's an entire module dedicated to what? Attacks. And we'll be also looking at vulnerabilities in the light of risk management. But then our emphasis here is on what? Protection of digital resources. Now, cybersecurity, what are we protecting? We're protecting one, digital resources. What are these digital resources? So it could be physical, virtual, or what? Or logical. I still maintain that. And also by extension, digital resources could also include what? Processes. Now, what makes a resource resourceful? What makes a resource resourceful? Now, one is ability to create value and deliver value, or is ability to either create or deliver value. Please note, from what you see there in the first bullet, is cybersecurity protection. Protection of what? Digital resources. Now, I like to say here that it's no longer limited to just digital resources. But I'm using digital resources. I'm emphasizing on it for a reason. I'll tell you why. But then, by extension, we're also protecting other resources that are not necessarily digital. For instance, in cybersecurity, we are protecting people, or we're protecting users. That's the right terminology. We're protecting users too. Are users digital resources? No. Are users part of IT? No. Are users part of information system? Yes. Do you get it now? Get the concept very clearly. Humans are not part of information technology. Information technology is just hardware, software, data. But humans are part of what? Information systems. Or, sorry, I'm using the word information systems in plural. Yes, that's how it's often used. Systems. Because a system is not just, what's actually a system? It's an integration of different components working together to achieve the same purpose. That's what we call a system. And by system theory, there are what we call subsystems. So the decomposition of a system will give us components making up a system, and each of the components in the system, in some instances, are systems themselves. Hope you're getting it. So, for instance, like I said, in the light of computer system, we have the IPOS, right? Okay. In information systems too, right? Then we have the input system or subsystem within an information system. We have the processing subsystem, we have the output subsystem, we have the storage subsystem, we have the communication subsystem. I hope you're getting. And you, as a cybersecurity expert, within that system, you're also a subsystem. The security operations center is a subsystem. I hope you're getting it. The data center is a subsystem. Because within this component, like the center, the security operations center, there are components too that make up that center. And by system theory, we put two or more components together, all working to achieve, please, two or more functional components that are working together to achieve same goal. We have a system. Now, I use the word functional. I want to emphasize on it here because I don't want to forget. It's quite important. In a system, please, let this also be your second take home tonight. For those of you where the day is evening, and for those of you where the day is morning or afternoon, please let it be your take home from this class. That first thing first, an organization is a system, and the organization itself has an information system. And within this information system, there are subsystems, right? Okay, now let's narrow it down to system theory. System theory says that this system is a fusion, an adjoining of different components. Now, there are two things key with the components. Number one, the components must be functional. Then number two, the components must be interrelated. Now, from the concept of system theory, he said is a fusion, an adjoining or a connectivity of the two or more components working together to achieve same purpose, right? The purpose is cause the overall objective of the organization, or a functional objective. When we functional here, departmental objective, for instance, operations in banking, customer relationship management, or marketing in any institution, IT. Now, these are functional areas of an organization with their own objective or objectives, as the case might be. Now, if we put a system within that functional unit, of course, the functional unit has an objective to achieve. So by implementing or a system, a technological system, or an information system, first thing first should be to actualize the objective of that functional unit. And secondly, cumulatively along other functions will not be to achieve the overall objective of the enterprise. Now, I'm leading you somewhere. Please follow the logical path. This is it. In that concept of system theory, there is this thing that is key. Components is a fusion of components. Now, these components must be functional, one, and two, interrelated. Functional, why are you stressing this? Why are you emphasizing this concept of functional interrelated? Because of cybersecurity. As a cybersecurity expert, if there are concerns within your system, the organization's information system or subsystem, please bring the concept of what do you call it? System theory into the analysis. Okay, why do we have an exploitation? Why do we have a compromise? Or why do we have a vulnerability? Are you getting it? And why, in spite of the measures put in place, our system was compromised, or is still, there was an attack that was near to success, but thanks to swift response, we were able to curtail it. If we had not responded swiftly, we would have been victimized by that attack. Okay, now the next thing is, why are we exposed? Why was the attack near successful? Let's look into the individual units that make up this system, the components. Can we identify a component that is not functional or is not functioning optimally? That dysfunction or lack of optimality in its functionality could be a vulnerability. And that's one of the reasons in software, there are software updates. Hope you're getting the concept. Now, number two is interrelated. If a component is functional, but is not interrelated with other components within a system, it can amount to an exposure, what we call risk factor. There could be a risk exposure from that lack of interrelatedness, which will now give rise to a vulnerability called lack of interoperability. So if two components, though they are functioning, but they are not related, there will be no what? Interoperability. If there's no interoperability and both are functioning, there will be a lacuna. There will be a gap that can be exploited by a threat. I hope you're getting it. Now, these are ways you can use towards one of the ways you can analyze a system down to its granule to identify, oh, I found it. This is the reason why the attack has been coming. This is the reason, in spite of the endpoint security or the antivirus we have in place, why we've been having virus attack. Oh, this is the reason why, in spite of this measure we put in place, there are still compromises. I hope you're getting, because you've broken it down to its granules, the system down to its granules, and trying to identify each component based on functionality and relatedness. Functional. So, but please, in doing this, now you're analyzing. You are doing what we call cybersecurity analysis. As you're analyzing, you must document. I hope you are getting it. In the light of risk management or cybersecurity risk assessment, there's what we call risk register. So you can either use an application and program dedicated to that purpose, Or you can customize Excel. You're quite good at using a spreadsheet so that you can keep your findings and then analysis can be done. I hope you are getting it. And with that, as a cybersecurity expert, you can identify the flaw and make necessary what? Suggestions. So in cybersecurity, first thing first, we are protecting. We're protecting digital resources. Now, what makes a resource is that its ability to generate value, one, its ability to either generate and deliver value, or its ability to either generate or deliver. It means the resource can both generate and deliver, because that makes it resourceful. Or it can generate but doesn't have the capability to deliver. So another resource can deliver, though cannot generate. Of course, that brings us to a concept called value chain. In value chain, there are those who are creating, there are those who are transiting, helping that value creation to who are helping to transit it, create mobility for it. And there are those who are delivering it maybe to the final consumer or from one point to another point and like that. And even there are those who are aiding the functionality or enhancing the functionality of the value that has been created. So every resource is resourceful if it can create value or deliver value or both at the same time. So cybersecurity is the protection of these resources. So of this resource. And then do not forget processes in the field of tech, in the field of cybersecurity, let me be specific, is actually a resource. Really? Yes. Banking, for instance, is a service. Please note from my explanation of what makes a resource resourceful, which I said for emphasis, a repetition for emphasis, being able to create and deliver value, or create or deliver value, as the case might be. Processes themselves are resources. Now, how can a process be resourceful? Is that process delivering value? Or is that process creating value? Is that process delivering value? Now, in the light of banking, teaching, I hope you're getting me. These are what? Service-oriented processes. Do they create value? Yes. Or do they deliver value? Yes. That makes them resourceful. I hope you're getting me. Please, I don't know. Do I have any need for a question? Is there anybody who has any question around for this? I'm trying to build something logically around this. I'll be making reference to this concept as we go. Please, as we go on, I'll be asking questions in between. Giving us like 2 minutes, 2 questions, 3 questions with objective. Let's answer. So please prepare your mind. So you do well by asking questions. Please, you do so well by asking questions, because I am not nice when it comes to asking questions. I will ask questions definitely. So we got protection of people also in the second bullet, financial data, commercial data, case might be. Then we have regulating fiscal access. All of these are part of what? Cybersecurity. You're regulating access-based fiscal access and controlling malicious intrusion and all of these. We'll see more about this as we progress. Domains of cybersecurity, network security, information security. We can go through this domain while you get the text or while you watch the video again. So you can see operational security here. And these are another aspects of cybersecurity that is trendy now. Yes, the post-lockdown made these last points very trendy, because during the lockdown, 2019-2020, with a spillover into 2021, so many institutions were exploited. And the mode of work was you resume, you log into their network and work using their devices. Okay. Sorry, Akintola, you want to say something? Hello, Akintola, you want to say something? It's saying your device. Okay, continue. Now, when the lockdown came and institutions, people were working from home, there was need to now work remotely. Configuration of information systems of most organizations' network changed. The change in that configuration led to exploitation, right? And When analysis were done, I could remember 2021 and global cybersecurity reports from some top sources I subscribe to. All of them pointed the cause of the cyber attacks during the lockdown to poor user education. So after those reports, the need to employ a cybersecurity analyst as an education officer, the need arose. So for most of the big names, big institutions within the cybersecurity function, we now have educators or trainers on cybersecurity. These individuals develop contents. So every time the organization has maybe a new security policy, they now have to educate, they now have to enlighten on how these policies should be implemented or complied with. So you may want to be one of these, a cybersecurity trainer. Of course, it's a job role now in the field of cybersecurity. So now there's information security and cybersecurity. Of course, I'm going to stay long here. Before the concept of cybersecurity came, we had information security. And then cybersecurity later came up, but did not replace information security at all. Rather, the word cybersecurity is taken from the word cyberspace. And all of us will agree with me that the cyberspace simply means the internet. So cybersecurity was primarily protection of what? The protection of digital resources on the internet, not the way it is seen today, not the way it is expressed. Cybersecurity is used today. Information security was protection of either assets, digital resources on the network or off network. Could be your personal, just your laptop, not connected to the network. Do we still need protection for that? Yes. What kind of protection? For instance, antivirus. Oh, can I contract virus through other medium or without media, without connecting to the internet? Of course, the use of flash. You connected a flash to a computer that is infected, and the flash is infected, then you're copying from that flash to your device. What do you think will happen? The device will be infected. So by installing an antivirus on your laptop, what is that? Because you're protecting. That's within the scope of what? Information security. But cybersecurity today has now taken over. It has become the household name for all other kinds of what? Security, including operational security. So these are domains within cybersecurity. We have information security, application security, network security, internet security, in some of these securities. Now, this is churned from ISO IC 27K, but the substandard within ISO 27K, the ISO 27000, sorry, we call it 27K within the light of the field of cybersecurity. Within ISO 27K, there are two broad categories. There's the 27001, there's the 27002. So 27001, which is basically ISMS, Information Security Management System. ISO 27002, which is basically now data security governance, majors on governance. Both are christened 27K. Now, within these two broad standards, inside one family called 27K, there are sub-standards. So there is a 27,032 sub 2012, that's the year, now has this feature, the different domains in cybersecurity. Please, you can see it's dated 2012. But like now we have what? So many domains within cybersecurity. So if you look at this box, you'll find cybercrime, these aspects, and cyber safety. So this man here, cyber safety, is meant to protect across any of these domains against what? Cyber crime. So by so doing, or by this implementation, we have what we call information infrastructure or critical information infrastructure protection. All of these are, this entire illustration is from ISO 27032. Okay, we also have these as an extension to security concepts and relationship. For those who take ISO 27001 certification would agree with me, all of these are key concepts within that journey, within that certification. So you are not taking an ISO 27K certification, so I'm not going to just brought this into it just for as a way of supporting, buttressing the concept of cybersecurity class. Now, let's look at it.
Sorry, I
Please
have
go
a
ahead.
question.
Please go
Please
ahead.
go back to, can you go back to the ISO? Can that help those who are looking into exploring GRC? Because it's all about the regulatory standard, ISO 27001, NIST, and so on.
Okay, thank you. You asked a beautiful question. Maybe because I'm not going to GRC here, that's why I didn't talk that much. But thanks for the question. Of course, it can, because ISO primarily is an information security. Sorry, ISO 27000 is an information security standard and framework rather than a cyber security standard. You may want to ask why. As at the time ISO 27000 or 27K was released, cybersecurity was just a standalone thing. It was, like I told you a moment ago, and cybersecurity was more of protection in the cyberspace, unlike what it is today. Right now, ISO 27000 was christened and is still christened ISMS. Please note, information security, not cyber security. Information security management system. Before the concept of cyber security became popular, protection of digital resources within a corporate entity was under the guise of information security. Hope you're getting it. And that is why we have some certification bodies still using information security to date rather than cyber security. For instance, ISACA, ISC Square, they still use cyber information security to date because what they're promoting is actually for corporate entities rather than for individuals. Why? EC Council was known primarily for cyber security, which is protection within the cyberspace. And to date, EC Council still holds on to the concept of cyber security rather than information. GRC. There is a key concept in GRC called compliance. For those who want to be GRC experts, of course, your skills must spread across the three: governance, risk, and compliance. And as a way of being responsible over the governance of providing necessary governance over information security systems, adapting one of the industry regulatory frameworks or standards is key. So for institutions, as a way of proving that their governance system or governance implementation, governance structure for information or protection of digital assets is up and running, is adopting the very popular standard, ISO. Hope you're getting it. So before we talk about compliance, there must be adaptation of the framework. So the concept associated with GRC, the concept of the practice of adapting a framework or a standard within the light of GRC is called governance. The practice of assessing our level of adherence with the stipulation of the standard or framework or law or regulation is what we call compliance. So before we bring in compliance, the governance must be functional. I hope you're getting it. Governance, because it is within the scope of governance that we adapt or adopt these laws, regulations, frameworks, standards, as the case might be. Why compliance officer now come up to do what? To measure level of what? Enforcement or our level of adherence, or generally our level of compliance. So as a GRC expert in cyber security, your knowledge of ISO 27K is very vital, but not limited to ISO 27K. Your knowledge of cyber security standards, we got ISO, we got NIST, we got CS, this CS or CIS, we got CIS, we got TOGAF, relates to GAF, now has the current version of TOGAF, and now has cybersecurity included in it. We got COVID-19, which also has security governance within its framework. We got what are these other standards? Of course, some other standards are not so popular, but then your knowledge of these security standards, those that are emphatic on security and those that have security embedded into the framework, your knowledge is very important, so that you can propose to an institution which of these standards of framework they should adopt, and by extension, carry out an assessment. For instance, ISO 27K has two certifications. There's the LI, licensed implementer. There's the LA, licensed assessor. Now, the licensed assessor is a GRC expert because his job is in the light of what? Compliance. I don't know if that is clear enough. Have I communicated? I mean, see, have I been able to explain that? Is that clear? Hello? Am I still audible?
Yes,
Can I
sir.
get
You're
it?
audible.
Oh, okay.
Very audible, and the explanation was very clear. Thank you.
Thank you, Adeleke. So let's build on it. So please, for just for sake of emphasis, if you want to go into GRC, you now know what the responsibility is. You must be very familiar with standards, frameworks, laws, regulations, and you can't be a GRC expert as far as cybersecurity is concerned. In Europe, I don't know GDPR, GDPR, because it's not going to work. Because though the data privacy experts needs to understand GDPR, the same thing too for the GRC. There are two different rules, two different areas of specialization. So both parties, both professionals must understand GRC. Oh, I have a long list for those of you in the US. I have a long list of specific cybersecurity laws and related cybersecurity laws. That is, laws that are specific on cybersecurity, right? Those that are related to cybersecurity. Even Basel Accord, the current version of Basel Accord, has a segment of it dedicated to what? To cybersecurity. Even if Basel Accord is not cybersecurity oriented, is governance oriented. But then, what about a Sabanes Osley's Act source? Of course, it has cybersecurity. Last review of source by the Congress, of course, they included cybersecurity into it. You understand? So these laws, as a GRC expert, you must know them. These industry standards, you must, even to the point of being certified, it is allowed. In fact, not allowed, it is encouraged. That to the point of being certified on these frameworks, these laws, or these, if they have certification for them, it is highly encouraged that you get certified in them. And lastly, for those going to GRC, you must be updated. That's one of the beauty of GRC. You must be updated. And the entire organization and the entire industry in which your client or your organization operates must be in your head. You know what I mean in your head? In your consciousness. The laws, the best practices, the policies, the government regulations, everything that affects that industry, either on a global scale or on a national scale or at the state level or industry level, must be you must know it. So please, we are thinking GRC is good. There are very few technicality with GRC, but so much knowledge and comprehension in GRC and up to date. Please, lastly, everything cybersecurity would put you on the edge. Go and note that. Everything cybersecurity. What I mean on the edge, you must be updated. You must know. You must be updated. You must know, because cybersecurity evolves. As technology evolves, it evolves. So you can't afford to be a backstander or to stay at the back. Even being at the middle is not allowed. You must be at the forefront. acquiring more knowledge through either more training or through professional education, some continuous professional education, and or through CPD training and all of that. Please note, protecting digital assets. According to NIST identified 4 key functions when it comes to protection of digital assets. First thing first, you must understand. First of all, you go to identify. What did they call identification here? Understanding. Use organizational understanding to minimize what? So first thing first, you must understand to be able to minimize risk. The risk associated with the system, assets, data, and capabilities. I don't want to talk about capabilities now. It's another extensive concept. Now, the next functional area within the NIST framework is protect. You don't only understand the organization and with that understanding minimize their risk. The concept of minimizing risk is key to risk management and key to risk asset because risk cannot be eliminated. Risk will never be equals zero. Risk can only be minimized. It cannot be eliminated. So being able to mitigate risk to a minimal level called residual level that the organization can accept is within the scope of identify. Then protect, being able to design safeguards to limit the impact of potential events. Now, when we say limit the impact of events, means that risk-oriented events that can occur, should they occur, their impact will not be heavy on the institution. Hope you're getting it. So you'll be able to design safeguards that can reduce the impact of risk occurring. Then that's within the scope of protect. Then you got to detect, being able to now implement activities to identify occurrence of cybersecurity events. These are another very critical skill in cybersecurity. But please note, this is within the scope of cybersecurity risk assessment. Oh, really? Yes. Is another area of competence in cybersecurity, risk management. For those of you who say you want to do GRC, within GRC, you can specialize on risk and risk alone. Yes, there's a route of risk. There's a route of compliance. So many institutions separated risk function from compliance function. Though they are separated, they are still within the scope of what? GRC. And lastly on GRC, here, let me say lastly now, is that if you're a GRC expert, you are 99% of the time going to work at the headquarters of the institution you're working for, consulting for. You're working at the headquarters. GRC experts are more, they operate at strategic level rather than at operational level. Hope you're getting it. So for those not in GRC, please bear in mind. And also, GRC can lead you to C-suite very fast if you can harness your skills very well. It can lead you to every job role in GRC has a C-suite job role. Go and check GRC vacancies you are doing. So there's a detect, being able to implement activities that can identify occurrence. I said this is a very critical skill in risk assessment, being a risk assessor and your ability to identify occurrence. That we are okay. There is from our KROI, that's from our key risk indicator, it is looking like this or this. Okay, let me not bring it down further. I don't make it technical. From our KROI, we can, from the flags, the red flags, how can we determine that this risk will occur? And in how many occurrences within a time frame, maybe within a month, a quarter, in 6 months, or in a year. Risk assessment must not exceed 1 year window. Please note that. I'll get risk line now, talk more about that. Then respond, take your appropriate action. The appropriate actions are called risk response. And there are 4 types of risk responses. There's the risk avoidance, there's the risk mitigation, there's the risk acceptance, and the risk transfer and sharing. We'll get to risk management class, I'll talk more about that. Then there's the recovery, the plan for resilience. That is where the business continuity manager comes in. Are you telling us business resilience is an aspect of risk management? Yes, take it from me. BCP, DROP, IROP, ICP, INP, ICM and all the response, and all the measures put in place to guide against incidents. They are all extensions of what? Risk management. And they are specialist roles. The moment you say, I want to be a disaster recovery or disaster business continuity manager or disaster recovery manager, you are taking a part of specialization already. There's nothing like, I do not, the only entry level I've seen in that route is incident handler. They call them first responder. But their job was really called incident handler. Other than that, most of the vacancies around business resilience is not entry level. But the job roles, the responsibilities are very strategic. So strategic responsibilities cannot be entry level. I hope you're getting it. So the moment you want to toe that part, you become a specialist. Okay. So that's that. Let's just go into module 1 now, see a few things in module 1, then we can call it a day or an evening. This part of the world is gradually getting dark. Okay, on the PM side, if you're on the PM side of the world, we can call it an evening. But if you're on the AM side of the world, we can call it a day. Okay, and these are the chapters which I'm looking at in this module. The list is quite long and it's quite interesting. So these are career tips, and I'll take you straight. CIA. CIA is the tripod carrying cybersecurity, or carrying cybersecurity, or let me say carrying security, carrying that assures the security of an organization's digital resources or resources generally. Because cybersecurity today is not protection of digital resources alone, but now protection of processes, protection of what? Infrastructure, physical infrastructure, protection of people or users, and so on and so forth. So cybersecurity is quite broad, but then the tripod upon which cybersecurity implementation is assured is called CIA. I just use the word assured, assurance. Assurance is cybersecurity. I mean, cybersecurity is an assurance function. I want to establish that concept now. Cybersecurity is an assurance concept. What is assurance? Assurance includes the following: 1, measures, practices, operational activities, organizational culture, structure, and the list is long. Or say measures that, we could say principles that an organization implements to ensure that it generates value and we continue so. I take it again. For simplicity's sake, assurance is a measure or all measures an institution implements to ensure that it generates value and we continue so. There are 2 keywords in value generation or value management. It is value creation and value delivery. It's not just enough to create value. It's more than enough by now delivering value to the right persons. I hope you're getting it. So CIA, the key objective of cybersecurity, guarantees that assurance from a security standpoint. So let's run into it. Let's get into it. It is the cybersecurity objective, like you see. I call it the cybersecurity principle. I call it cybersecurity tripod. Like it is said to be a triad, of course, a triangle. It can form a triangle. Now, this is how you can connect with confidentiality. I will be using it across instances, and it might be looking sometimes that they look alike. Most especially confidential integrity. In some instances, they look like the way you explain it. It's not like the way you explain. I hope you are getting the way you explain it here. It's not like the way you are explaining it now. So let's see.
Lost you somewhere.
See.
Yes, we can hear you
Sorry,
now. We
can you hear me?
lost you at some point. So if you can help us repeat it, we won't mind. Thank you.
Oh, okay. Thank you. CIA, as you see on the screen, CIA triad, I christen it the tripod upon which cybersecurity is centered. In fact, it is a pivot of cybersecurity. Yes, CIA is a pivot of cybersecurity, is the hallmark of cybersecurity, is the foundation upon which all cybersecurity measures, all cybersecurity techniques, all cybersecurity implementations are centered. If you call yourself a cybersecurity expert, you must know the nitty-gritty of CIA, not by referencing any text. It must sink in you. I hope you're getting me. It is quite easy to memorize the definition of CIA. But when it comes to implementing CIA, that is the crux of the matter. I hope you're getting me. So CIA is that tripod, is that center of gravity of what? Cyber security. So let's get into it. And for simplicity's sake, I want you to just remember the following as it's associated with CIA. Confidentiality simply means protection of access. I hope you're getting me. No, cybersecurity is protection, right? Now, confidentiality simply means the protection of what? Access to digital resources. Are you getting it? Integrity means protection of what? Modification. Please note. Availability means protection of usage. Really? Yes. Please, I take it again. The protection of access to digital resources is confidentiality. So that protection will come in form of what? Authorization. That protection will come in form of what? Permissions. Who is permitted to do what? Who is authorized to do what? So it means it's either you are what? Permitted to, or you are denied. I hope you get it. It's either you are allowed, you're authorized to access it, or you are denied access. So confidentiality will be protecting access to in the light of authorization or permissions or denial. You get it now. So if it means if I am denying access, your access to a database, I'm enforcing confidentiality. If I'm granting you access to a database based on your job role, I am also enforcing what? Confidentiality. Get that picture, get it very clearly, and let it stay with you, please, without you having to reference any text. So I am granting you access, I'm protecting. I am denying you access, I am also protecting. The same thing to apply to integrity. Of course, digital resources can be modified, can be altered. As basic as data, as basic as instructions, program instructions, or algorithm codes can be modified. I hope you're getting it. Not only that, can hardware be modified? Yes. How can hardware be modified? Their configurations. We can change the look of what? Of a router. But we can modify a router. How? We can modify the configuration of the router. Yes. For instance, for the small size network devices, we now have routers, or I call them wireless routers, that can be modified to become extenders. Is a router it's a wireless router, please note, by default. But that's what extender capabilities. So we can do what? Disable routing capability and enable what? Extension capability. So what are we doing in that light? It's not acting as a what? As we're using that router to extend the network. Because basically, I mean, a wireless router providing wireless access, or let me say an access point, is limited. The explanation say as explained in the protection terms. Sorry, Adekunle, can I get it? Can you unmute and explain? I don't know. I think I did not get that clearly.
Hello.
Yeah, go ahead.
Yes, I'm just trying to say, can you please explain what you just explained about the CIA triad in the matter of protection of access, authorization or denial, and I get the one for the availability, protection of its usage. So for the integrity, it is protection of what?
Okay, thank you. Modification.
Okay, protection of of information.
Yes, protecting the modification of what? Of digital resources. Please note, is modifying a digital resources harmful? No. For instance, you can modify configuration. It's not harmful. You can update an operating system. It modifies the last state of the operating system. Yes, it does modify. By what? Either enhancing its features. Does it make it harmful? No. But then that modification must be authorized. I hope you're getting the concept. So when we say access, of course, is not bad, but at the same time can be harmful. So what do? We protect it. Modification is not harmful, but at the same time it can. So what do? We protect it. So if we protect access by enforcing only authorized persons can access or can access the resource, unauthorized persons are denied. That's called confidentiality. Integrity, protection of what? Modification. So it means only an individual or user who is authorized to modify a state, a digital state, can do that. If you are not authorized to modify that digital state, you are what? You are denied. Hope you are getting it. So in that sense, what are we protecting? Integrity. For instance, rolling out an update. Okay. What measure do we put in place to ensure that the updates to be rolled out does not become harmful? Because updates are meant to be useful. Updates are meant to augment protection or functionality. But at the same time, they can become harmful if they are rolled out, if either they are rolled out wrongly or the codes, the instructions are not properly written. So what do we do as well protecting that modification is to now do what? Put measures in place that, okay, the update must be tested once, twice, what we call testing techniques that must be put in place before, and then there must be some authorization before the updates can be rolled out, because every update would change the last state of that technology, whether it's software, firmware, or I hope you're getting the configuration of the what of a network device like a router, or even configuration of the what of your computer system. Hope you're getting it. So integrity is protecting modification. So it could be protection for authorized, only authorized individual can modify, or denial to what? Unauthorized individual. But the emphasis is protecting modification. Then the last one is what? Protecting usage. They can be abused. So what do? We enforce a level of protection so that you can only use a digital resource based on your job role, if it is stated that way, or based on some what? Some permissions. Or on the flip side, you can only use to the extent you are authorized, to the extent you need it. And that's what I call on need basis. Not everyone should have equal access to all the resources in a database, for instance. Some can have more access, while some have less. A very good example is access to view and access to copy, or access to, for instance, download, like you have on the internet. Some resources cannot be downloaded. You can only view if they are in PDF or downloadable format. I hope you are getting it. So protecting usage is what availability addresses. I hope you are getting it. So there could be unlimited restriction towards usage, and there could be what? Some limitations to usage. Let me give you a clear example in the light of telecommunication. There's what we call FUP in telecom, fair use policy. Fair use policy is one of these policies used by telecommunication companies to enforce what? Usage, availability. Okay, how does it work? I have unlimited. I subscribe to unlimited bundle. So it means that I can use as much as I can. It does not apply in telecom that way, in the light of fair use policy. That you are giving unlimited still doesn't mean there are no restrictions. Yes, can ask the telecom workers, they will tell you that you're given unlimited access. That's what you subscribe to. Still doesn't mean there are no restrictions. There may now be restriction on what? Uplink and downlink. Sorry, I'm not trying to get this model. For those who are not technical in the house, your uplink, your downlink are usually measured what we call Mbps, megabits, not megabytes, megabits per second. So the amount of bandwidth you can consume per second in downlink will be restricted. Even if your device is capable of what, maybe 100 Mbps, the service provider might just restrict it down to what, to 30 or to 20. I hope you're getting. Though they said it is what, unlimited. That's the claim as far as that plan of the case is concerned. But there's the FUP. Okay, we said it's unlimited. Doesn't that mean you should just? It's like say somebody giving access to a pool of water, a reservoir of water. Because we said you have access to the water, doesn't that mean we should not regulate how much it flows? You could just be wasting it. At the other end, you can leave the pipe open and you're not using it. So why the water is just gushing out? So why don't we limit the amount of flow that gets into that pipe? So even if you're wasting it, at least it is restricted to an amount. I hope you're getting it. Sorry. I can go on and on in telecommunication. There's a way they enforce this thing. So for those in telecom, they understand the way it works when it comes to data bundles and all of that, data usage. So with fair use policy, they are enforcing availability. So I am going to at least note these three. You may ask me questions around this. I am going to ask you questions, tricky questions around them. Let's see.
So, because
What
of
is this?
time,
Yes.
I'm just thinking that we should
Okay,
draw the
yes.
curtain for today,
All
and
the match
we're gonna be doing a deep dive on this tomorrow.
Okay.
I don't know. It's been an insightful full session for me, even as a person, and quite a lot of refreshing stuff. I can't even believe that this is the content. Yet I stood up. I've been standing since we started, and I never felt that I was standing at all. So that's good. A lot of people have been asking questions whether or probably thinking of what are we going to do. So we're going to upload this recording and we're going to share it with everyone tonight so that you can catch up with whatever thing that's been said in preparation for tomorrow. So we continue this class same time tomorrow, and you're going to get a separate invite tomorrow. We're trying to see how to. There are quite a lot of teaching administrative things that we are dealing with, but we'll soon uh, automate everything. Everybody's portal is ready. We have created it. It's just to share you the login details so that you can have access to all these resources. We have books, we have materials that we are going to expose you to. We have slides, we have videos that you're going to have access to. So then from there, from the portal, you can do your assignments. You can, there's a forum, there's an assignment, and I think there's a test. If probably we'll just want to test your knowledge, every domain that we've been talking, every module, we're going to be testing knowledge so that we're going to know whether we are on the same page or not. And the fact that your score doesn't really matter, it's just to assess your level of understanding of the concept so that we'll be able to know how best we can support you as we progress on this journey. So I don't know if anybody has any question before we draw the curtain for today. It's been an extensive 2 hours session, and it's been insightful for me. I don't know if anybody question, any comment whatsoever before we draw the curtain for today's class. Has it been valued for our time?
Hi, this is the last one. Okay, the class was really insightful. I've not really sat down as well, but I enjoyed this. I've been on the move multitasking, but I was seriously listening. Thank you, Mr. Function Phoenix, for the trade. It's for the class. It's really nice. It's really nice.
Thank you. Thank you. That's encouraging. Thank you.
Also, I just want to say thank you for this particular session. Last year for like 8 weeks, I I was in a boot camp for IT audit and GRC, and it was refreshing, for me to hear about, how important, ISO 3000, is to GRC, because of the governance aspect of it, and the importance of uh, IT audit also, you know, as a particular component of cybersecurity in general. So it's refreshing. Last year, I was basically sleeping through all those classes. I think that's one of the reasons I'm here. So I'm looking forward to because I'm driving now to work. I slept like 15 minutes in this class, but when I started hearing some things, I couldn't sleep anymore. So it's
Wow.
quite stimulating and engaging, and I'm looking forward to, building my capacity and having, practical hands-on, you know, experience through the process, and also engaging with everybody. We can kick on each other's brain, and as a team, develop a win-win situation for a more rewarding career
Wow.
in cybersecurity generally. Thank you so much for this session. Yeah.
I,
Thank
I,
you.
I agree
Thank
with
you.
that. I agree with that. It's been a real value for our time, for my time, anyways. I can't say about other people, but for my time. Mm.
Thank
Well,
you.
thank you
And when
very
we
much.
get to GRC, thank you. And when we deep dive into DRC, then your eyes will be widely opened. So we just, I deliberately mentioned or asked the question about the importance of ISO to anyone that is trying to pursue career in GRC. ISO is not the only one, depending on the organization you're working with. Some organization adopt NIST, some organizations does ISO, and some organizations, depending on the maturity or the capacity, if they are operating across globe, they look at some areas of convergence. So, and that's the capacity we are trying to build you on, and some other frameworks like that. That for UK, some organizations do either NIST or and what's it called, Cyber Essential Plus. So we're going to be exploring quite a lot, as in, and the list is highly inexhaustible. So, but then, we are just getting started, and all these that we have done today is just a tip of an iceberg, and they are just introduction. So, I want to thank you for your participation and for your attendance, and we really, it's encouraging for us to see or to know that it's been valued for your time. And as promised, we're going to make sure that the recording for today reach everyone today. And in preparation for tomorrow, we're going to send you the link for tomorrow, and we're going to get started at the same time. Someone is raising his hand. Ayokumi Pacheda, please. You have the floor, sir.
Emma Sheshao, thank you so much. Yeah, I want to find out. It's very insightful, and I really appreciate the class. I want to find out if we are going to be having like like you guys are so experienced in this, like
We'll give
practicals.
you we'll give you the
There was a time I
we'll give
had
you all the exposures you need. All the exposures,
yeah,
all the exposures you need. Things that we are going to be proud of,
because
and things that you yourself will be proud of. We want to cook you and equip you and
uh,
make you a subject matter expert in whichever field you want to go, you feel you
you
want to
know
pursue.
I've asked you some questions before. You said because of confidentiality. That's why you said you cannot expose me to some things.
Yes.
That
So
time.
so
So
because
thank
this is a training, and we already have some cloud environments. Yesterday we had the instructors meeting, facilitators meeting, and we're diving deep into so many materials and so many tools that we're going to be exposing you to. So we are going to be communicating that. We're going to be creating accounts for everyone. You see the environment you are going to be working. You see a lot of things. So, like I said, it's going to be it's going to be an interesting journey for all of us. So, but
I,
any
I
other
also,
question? Okay.
yes, I also have one more question. I wanted to ask how
many days in a week are are we going to be?
So we're gonna be doing 2 days in the week
Okay.
and 2 hours per session, like we have for today. But then learning continues rather.
Mm.
Everyone is going to have a portal. You're going to have some materials. You're going to have some things to catch up with. And we understand the fact that people are busy as well. So we're going to make sure that we put that also into consideration. But then for live practical sessions, we're going to be having twice in a week. And for those who because I know we are working across different time zones and it's not compulsory, it's not convenient for some people to join this call, but they at the same time join. We're going to be making appropriate provision for everyone. And that's one of the reasons why we sent message to everyone ahead and said, communicate your availability so we can work and plan with it. So thank you. Any other question? Any other
Thank you.
question?
Thank you. I think you addressed my own question because I was going to ask about time zones, but I think you have said something about it. So
We've
we
got you
just hope that,
covered.
yes, thank you so
Thank
much.
you. Thank you.
I want to say thank you at this juncture to everyone for coming to class today. Thanks for the feedback. We are promising you so for my namesake, who said this center. Okay. You're welcome on board. I'm laughing because I'm a systems auditor too, and I'm a practitioner. So welcome on board. Though this journey doesn't have so much of system, but the system is another route entirely. But then you always see that part in me, expressing class, that systematic part. We're not there yet. Don't worry. Assuring you that thank you, everything. Thank you. So let me draw the curtain here so that we can all to our task signings. Thank you once again. Have a lovely evening for those of you on the PM side of time. And a lovely day for those of you on the PM side of time. Enjoy the rest of the day. Bye, everyone.
Thank you, sir.
Bye. See you tomorrow. Thank you.
All right. Thank you very much. God bless.
Yes. Amen. Thank you. Please, can we stop the recording?
Yeah.